This is Physics 2212 Lab 1, Charged Tapes. So in this lab we're going to be preparing two pieces of charged tape and then examining and determining the interactions between the tapes themselves and objects around them. We're going to determine the excess charge on one piece of tape and simulate the interactions with GlowScript. And then we're going to find all of this later. So, an introduction, some key concepts we have are Newton's second law, where F net equals dp dt. The gravitational force equals negative mg in the j hat direction, where g is 9.8 meters per second squared. And then we have the electric force in the top right, where Q1 and Q2 are the charges of the particles, and Ke is Coulomb's constant. And then here I have some assumptions in order to conduct the experiment. So we're going to say the tape acts as a point charge and is located in the middle of the tape, and then we can model the tapes as a singular point charge in GlowScript. So we're also going to say air resistance is ignored and that both tapes have the same charge because we created the charge in the same way. Here are the lab steps that I did. I first created the U-tapes by putting one piece of tape on the table, putting another piece on that piece of tape, and then pulling it off. And I did that twice to create the two U-tapes. And then I observed the interaction between the two tapes, between the tape and my hand, and then between the tape and a pin charged by running the pin through my hair. And then created this setup right here, where I suspended one piece on two level blocks and then held a second piece of U-tape and observed that the top piece went up and floated. So there we go. So while observing the U-tape, I found that when you put the two U-tapes together, they repel, and then the U-tape is attracted to my hand and the U-tape is attracted to the pin. So we know that the U-tape is actually positively charged because we know the pin is negatively charged by running it through my hair. So then when we suspended the U-tape and held the U-tape below it, they were separated by a distance of 0.023 meters because they were repelling each other. So that's going to be the magnitude of our vector r. So here's just some data that we have to work with of the tape, and we use it in some calculations later. Here's some of the calculations. We calculate the force of gravity first and find this number, and then using force of gravity we use this formula to find the charge of the U-tape, and then we can find the deficient electrons by using this formula, and finally the ratio of deficient electrons to atoms. Here are some constants and forces that we're calculating. So here are the constants, here are the forces, gravitational force and electric force. So in this part of code, we're just calculating and visualizing said calculations. So all of this right here is going to be calculations of charge, deficient electrons, atoms, and ratio of deficient electrons to atoms, which we found earlier. And then we're going to print that stuff out, and then we're also going to visualize said forces in the simulation. So as you can see here, the results show that what we described is true. This top ball is representing the suspended tape and is going away from the one below it, and all these numbers here are the same of what we got earlier. Concluding, we know that the tape has a positive charge, so there's an electron deficiency, and for the U-tape to float we have to have static equilibrium, which means that there's a net force of 0. And then some possible sources of error are just inaccurate measurement, rounding errors, and not holding the U-tape correctly. To answer the what if and why questions, if the electrons had positive charge and the protons had negative charge, the observations would actually be the same, because they're just switching charges, and since like charges repel and unlike charges attract, the same thing is going to happen. And then why is it important to handle charge tapes as little as possible? That is because when you handle them, there's going to be some electrical discharge onto your hand or onto the tape, which is going to mess up the charge on them. And that's it.